So welcome back to our tutorial. So in this particular exercise, we continue from what we have done in the last one. So in the last exercise, we complete a quite sophisticated exercise by using, first of all, a particle system over here. And in combination with what we have done in last couple of exercises, the motion detection over here. We make use of the information, the X and Y information from the motion detection by using the pix block and to obtain the X and Y coordinates and send it back to an orbit point from the particle system. We use it as a force to control the movement of the particles. And in this exercise, we try to keep, for example, the motion detection part and modify part of the particle system such that we can have similar but a little bit different effect. First of all, we do not need the path orbit point to attract the particles. Instead, we'll make use of other function from the path source. So basically, we keep the other things. For the path source, we take a look at the head. So beside the first inlet, the second one will determine the number of particles per frame. And the third and the last one will actually determine the forms where you would like to emit the particles. So what we are going to do is try to relate the X and Y and also the Z coordinates, which is obtained from the pix block information, to fit into this particular position, the last one, and then also the last but one. So we'll make use of the idea or the domain we call the point, which is a single point in the space where you would like to emit all those particles. And the extra arguments will be the coordinates of that particular point. So the modification will be something like this one. We put in a dummy number which indicates the initial particles per each frame. And then the second one will be a point, and the point to indicate you would like to emit those particles from a point which is provided by a coordinate right here. And in terms of the coordinates, so actually we have already computed that particular coordinate in the last exercise. So actually this is the send P, that is the point. All we need to do is just add in the receive over here. So you will have the coordinate sent from here and receive right here. And this number, we can also use it to modify the number of particles per frame. So at this point, we can do a very initial trial one of the patch. So we initialize the size, create the window, start the rendering, and also the lighting. So at this point we have kind of huge particles. So actually we can reduce the size. And increase the levels of details. Or if you like, you can change the color. and also modifies a little bit of the speed. And also the age. And if you want, you can also change the number of particles created per each frame. So this is the particle part, and we shall go back to this area to initialize the tracking. And then you can move along in front of the camera in order to see the response from those coordinates. And after that, you can do the live testing by moving some objects in front of your camera. Those are the initial response we try to modify, for example, the path source, and use it as a point to emit the particles. And in order, for example, to simulate the natural phenomenon, we can also add in another effect, which we have learned before. It is the gravity. So I add in the path gravity with the value 0 for the x direction, minus 0.03 for the y direction, and then zeros again for the z direction. So it's kind of simulating the natural phenomenon with the downward gravity force. So we can have a look at the additional effect. So at this point, the objects or the particle will fall down, and you can also modify a little bit of the initial velocity. So this is the overall effect. And other than using this sphere or three-dimensional objects as a way to generate the particles, we can also make use of other physical form. For example, we can make use of text. So in this case, I replace the sphere by another visible form. So we make use of something new we call the text. So text comes with 2D and 3D. So the 3D one, you have more flexibility in terms of rotating and moving it around in the three-dimensional space, but at the expense of the clarity, because in the text 2D you have the anti-alias, but in the text 3D you do not have the option for the anti-alias. For text, you come with two parameters. The first one is actually the piece of text you would like to display, and the other one will be the size of the text, and those other information you can also specify, for example the font and some of the typographic controls like the justification. So I'll put in, for example, a piece of message which is actually a message with the prefix text. So I'll use the text3d to put in over here. And the second parameter will be a number. And you use this number to control the size of the text. So with the part color, you also use it to control the color of your text. We'll do a try one for this one. So initially, you only see the text ggm, which is the initial value for every form of the text. And if you would like to use your own text, you just need to click upon the text message box. So it will replace by your own text. And then you can modify, for example, in the number box, the size of your text. You can also modify this number in order to produce a little bit more of those particles. So this will be the effect we achieve through the use of this option by using the path source as a way to control the location of the emission and also the gravity to control the falling down of those particles. And we use the text as a way to replace all those spheres we have done in the last exercise. And you can use the text message to change actually the text. So in case you have multiple texts, you can, for example, use multiple message boxes over here in order to switch between one text and the other. So in this exercise, we try to combine actually what we have done in the last version using the motion tracking and also a particles system, and combine them to work on with another form of the effect.